Welcome all of you. So we're going to discuss about that sequential circuit. What is a sequential circuit? So combination logic plus memory element. These two is combined is called a sequential circuit. What is combination logic? It's an open loop system. They mean no feedback. So yeah, a number of input and m number of output is produced plus memory element. What is memory element? Flip flop. So flip flop is a memory element. Okay. Okay, next one, types of the sequential circuit. So in that one, next what we are going to see about that one, after flip-flop, sequence of the circuit it include for that a synchronous counter and asynchronous. So generally synchronous or asynchronous, what is the difference? So both also output changes. Yes, okay. So only at a specific time or at any time. So only specific time means that is called a synchronous. Asynchronous means at any time. Further, this sequential is it is included for that multi-vibrator. As similar to that 555 multi-vibrator, here also the class of the sequential circuit. There are three multi-vibrator. One is bistable, monostable, astable. Astable means no stable state. Mono means one. Bistable means two stable state. So here, what are the two okay? What are the two bistable means? It's include for that latches and a flip-flop. So bistability is include for latches and a flip-flop. Okay, latches and flip-flop are flip-flops different methods used for changing their states. The next one is a memory element. We're going to see memory element. Memory element is nothing but it is a flip-flop. So what is that purpose? You will going to give the command and it will going to store the Q value. A device which can remember the values infinitely. So memory device is it will going to store the value infinitely. Change the value on the command from its input. So it will going to change the value and output based on the command input command. The q it is will going to change. The q value it will going to change either 0 or 1 or a toggle. It will going to change based on the command input. What is that command input you will going to give? So either the command input you can give on that 0 or 1 you will going to give. So 0 denoted for that reset, 1 denoted for that set. So in that one is a q. So q, another one is a q, q plus, not a q bar. Q bar is a different q plus. What is our q plus instead of that q of t? Q of t plus 1. What is that one? Current state or present state, next state. So about that one. Okay, so here is a current state and a next state. So current state is a don't care. Next state only the value to will go to present. Reset means 0. Then set means 1. Okay. Then further here is a no change will come. Another one is a toggle will come. We're going to locate on that one. So memory element. Memory element means this is a memory element. What is the memory element? Flip flop. Flip flop plus clock signals. Okay, memory elements. Okay, memory elements with a clock. So flip flop are the memory elements that change the state on clock signals. It will going to change with respect to the clock signals. The clock it has there are two methods. One is a edge, another one is a pulse. See that one, edge and a pulse. What is the edge? Edge means this is a left edge, then right edge. There are two edges available. Then left edge you can say about that positive edge. Okay, positive edge. It's moved from that 0 to state to 1 state. It is moved from that one 0 to 1 left side. Okay, that is called a positive edge. It is moving. Increase means that is called a positive edge. Negative edge means what about the negative edge? It is a top to bottom. It's moved from that 1 to 0. It's moving. That is called a negative edge. Okay, another one is a pulse. Pulse it is contained that are two pulse. One is on pulse, another one is off pulse. So on pulse means 1, off pulse means 0. That's all. There are two pulse and two edges. Okay, so these two is types of the triggering or activation you can say. Pulse triggering, edge triggering. So edge means move from that 0 to 1, positive edge, 1 to 0, negative edge. Then pulse triggering, on, off. So on, off. On means 1, off means 0. Okay, then edge triggering. Yes, positive edge means move from that 0 to 1. Okay, and negative edge means 1 to 0. Then next we will going to look about the flip-flop. Flip-flop, when you will going to see the flip-flop, there are three type of flip-flop you will going to see. SR flip-flop, JK flip-flop and D flip-flop. When you will going to look about these three flip-flop, it's a circuit diagram, truth table and yeah, circuit diagram, truth table, almost similar it is coming. Only one thing you want to know, okay, SR flip-flop. What is SR flip-flop? Here clock signal is applied. Clock is a pulse, is you will going to apply as in once. Okay, on pulse. Yes. Next one is the see. There are four NAND gate is used. Here is yes is a one input, R is another input. The output of the NAND gate is giving to that giving to that this NAND, and one more input is a from fourth NAND output. What is this one? QN bar. Okay, here see that one. It's a present state. This is a next state. Present state. Next state is available. Okay, so like about that one circuit diagram is designed. Okay, this is about that SR flip-flop truth table circuit diagram. What is the truth table? So clock is on. Okay, then 00, 01, 10, 11. These are four possibilities. Then present state don't care, don't know. Okay, then next state only you will going to write. Then no change. See that yes value 0. The same 0 you will going to write 1. Then same 1 you will going to write. Then fourth state 1 means invalid. Okay, not applicable. That's all. So then you will going to prove it on that one steps. It is very simplest one. So like about you will going to write about that SR circuit diagram and the truth table. The next one JK flip flop when you will going to write. So clock is same. J you will going to write and K you will going to write. Don't care. So what is that one? Present state and next state. First row is the same. Second row also same. Third row is same. And the fourth row instead of the invalid. Okay, you will going to write about the toggle. That's all. Toggle only you will going to write. Under circuit diagram, this is a point QN bar. It is coming to here also. In that point, first NAND gate consists of three input. Similarly, the QN is coming to here, and the same QN you can connect to that this NAND gate also three input. So three input first one and three input on that is this one also. So here you will going to write J and here you will going to write the K. So just look it on that JK. Yes, see here that one is qn plus 1 it is coming here bar and the same value it is coming to here. Qn plus 1 it is coming here and then same value it will going to give. So it is a it's a next state. So present state only you will going to give it. So present state value yes. Then here you can say first row same, second row same, third row same, and fourth row only toggle only you want to replace. The next one D flip flop. D flip flop, you remove the first row and then fourth row you can going to remove. Okay, you will going to remove. Then if you once you will going to remove. Okay, in the go to the SR flip flop NAND gate, not latch. Yes. So you have go the first row you can remove and the fourth row you can remove. Once remove, keep it only yes only. 0, 1. Then output is 0, 1. That's all. So there are two input is there in SR. So you will going to make it on that only one input. How to one input means only one input you can go to the this point, and in that one NAND gate is used to you can connect it to that OR. That's all. So you will now you will going to look at the diagram. See, so the same SR flip flop we will going to draw. So here is a point is a 1 and another one is this take the one not gate, another one is connected to here. So here is qn1 and qn bar. It's a present state. Then next state values. Okay. Yeah. So here is 0 means 0, 1 means 1. That's all. Use the formula. Very simple steps. You will going to do it. So this is about the flip flop. So flip flop about that one. SR flip flop, JK flip flop, and D flip flop. It's a common. The next one is when you are going to go into look about the SR latch flip flop. Instead of the NAND, only they are using for that NOR gate. NOR gate is used present state, present state on the bar, next state bar. Here where is that one R is used? Here is S is used. The same four steps 0 0 0 0 0 1 0 1 1 0 1 0 1 1 1 1. So here is a what about that one? There are two possibilities. Either you can go to give for that 0 or 1, 0 or 1, 0 or 1. What about that qn plus 1? That is the same. No change. 0, 1, and the one is invalid 0. This is called about that SR latch. Okay. And when you will go for that master slave flip flop, what is a master slave flip flop means? Like you can take for example hard disk. Take the one of the hard disk. Okay, normally every system computer it has that one hard disk is there. Okay, hard disk it will going to store the data. Okay, one of the permanent storage device. Okay, if you want to connect it one more hard disk into the computer, already one hard disk is connected, that is called master hard disk. One more hard disk you will going to connect it. Suppose both hard disk also OS is there. both hard disk also. One hard disk, first hard disk is a Windows 7, second hard disk is a Windows 10 is available. So what will happen? There is a possibilities about that Windows 7 booting as well as Windows 10 booting. Then what we want will do normally, one is act as the master, another one is act as a slave. Slave means just only access about the data from the colon C colon D colon E colon. So that's why what they will going to do, there is a one jumper available on the second jumper available. Just to remove the jumper means it's a slave mode. So you will going to normally connect the second hard disk into the system. That's all. That is called a slave mode. Similarly, come here. There are two flip-flop available. Okay, JK flip-flop 1 and JK flip-flop 2. There are two flip-flop. There are like the hard disk. Okay, one is act as the master, another one is act as a slave mode. Okay, how it is the can make the connection means, okay, J is input and then K is also input. There are two input, J and K, and a clock signal. This clock signal, okay, now use one NAND gate to that another input, another flip-flop clock signals. Use the clock signal, just a NAND gate used to, you will going to give the second flip-flop clock inputs. So whenever this clock is 1 means this clock is a 0. Whenever this clock is 0 means this clock is a 1. Okay, then another one is the first flip-flop output is fed to the second flip-flop input. First flip-flop Q bar is the output is fed to the second flip-flop input. So this is a method about that, a master slave method. The same thing you will going to draw the circuit diagram. So first master flip-flop you will going to draw. Okay, master flip-flop you will going to draw about that one. NAND gate 1 2 3 4. Okay, you will going to draw. So first NAND gate, it consists of that one. There are three terminal. Okay, then it's followed by that second flip-flop you will going to connect it. There is also you will going to connect it. 1 2, here you will going to connect it. This output is a fed to that. This is a point. This output is a fed to here, and followed by through two more, and the final output is there. This output you will going to take it and connect it to that in here, and this output you will going to connect it to that here as usual of that JK flip-flop type. So you will going to connect it, but only one. Here is a JK 3 input, but here is a 2 input only. So like you will going to develop about the circuit diagram of that master slave JK flip-flop. So here clock pulse is on, here is a clock pulse is off. That is a, it's active, it's a inactive. So that is only differentiations. Okay, this is about the master slave JK flip-flop. The next one is the edge and then level. Edge and a level. If I have look here about that one, the positive edge. Positive edge means 0 to 1 is moving as a positive edge, and 1 to 0 means negative edge. Positive edge triggering, negative edge is triggering. Then level triggering. So level means on, that is called a pulse. Another name is level is another name is called a pulse. So it will go to on pulse and off pulse. So it will going to change. Okay, change in the circuit happens. Okay, on pulse and off pulse, it will going to change it. The next one is a counter. We're going to look about the counter. The counter, it is include what, that is synchronous counter and asynchronous counter. There are two counter is there. Okay. Yes. So what is the difference between the synchronous and asynchronous? We already discussed. Output changes both at a specific time or at any time. Okay, synchronous counter, another name is called a parallel counter. Asynchronous counter, another name is called a ripple counter. That's all. Then what is a synchronous counter? A synchronous counter is a same clock pulse for that. All flip-flop is the same clock pulse. But what about a ripple counter? First flip-flop output, complement output to the second flip-flop clock signals. So I will show you. See, this is a synchronous counter. Clock pulse is common for that all the flip-flop. Yes, clock pulse is common for that all the flip-flop. Then first one output is second one input. Okay, they are giving, that is called a synchronous counter. Okay, asynchronous counter means what? So this is asynchronous counter. The first one complement output. First one output complement output to the second one clock input. First one complement output is the second one clock input. That is called asynchronous counter. So synchronous counter, asynchronous counter is over. So what is a synchronous counter? It's a truth table. So just you are going to look the truth table clock. So initially 0 output also. Second flip-flop of that one is Q2. Then after that Q1. Q2 is 0. Q1 also 0. So second flip-flop. Then after that first flip-flop. So whenever you will going to work executed, So you will going to do easily second flip-flop followed by the first flip-flop. So when clock pulse is 0, 0, 0 is coming. When clock values increase 1, 2, 3, 4 plus values. If when you want to increase, then what about that result? You will going to write about that one. So Q2 this is a result, and then what about the result of the Q1? Okay. Okay, see, very simple to writing about that one. So okay, clock is the first initially 0, so output is both flip flop is 0, 0. So first we're going to look about that one. So clock pulse is you are giving, so all the clock pulses you are increasing the clock pulse 1, 2, 3, 4. So plus clock pulse you are going to give. So when you will going to give, what about that one here? Just you will going to see that one Q2 first. See here, so Q0, this 0 is coming to here, 0, 0 input, JK flip flop, 0, 0 input, what is output? No change, 0 only. Yes, return the 0. Okay, then this 1 is coming here, this 1, 1 input, what is output? 1, 1 input, output answer is toggle. Toggle means 0 is replaced into the 1. Yes, the next one 0 is input, 0, 0 means no change, the same 1 value is repeated. Then 1, 1, 1 inside 1, 1 of the JK input means that is called toggle. 1 is replaced into the 0. That's all. So 0, 1, 1, 0. So that is this written here, 0, 1, 1, 0. The next one. After that you will coming to that Q1 input. See here when you will going to see there is a square bracket is I have mentioned bottom side. Why I have mentioned the square bracket means this square bracket is the answer. So 1, 0, 1, 0. That is answer. 1, 0, 1, 0. How it is coming? So why it is written on the square bracket? You know that is the answer. This is a previous value. This is a present value answer. That answer is coming to that one previous value here for reference purpose and a present value. And this 0 is coming to here for that reference and a present value. And this 1 is coming to here top for reference, that is called previous value and a present value. So previously 0, yes, you have look at 0, this 0 is I have written. Okay, so 1, 1 input, okay, J is 1 and K also 1, clock also plus. So if it is 1, 1 means toggle. So toggle means shifting. From where to where shifted? That's why reference 0 to 1 is shifted. Okay, fine, good. Next one is that one I have written for reference purpose. Then now you can apply for that one again toggle. Toggle means 1 is shifted into the 0. The 0 is I will going to keep it here for my reference purpose. Then 1, 1, okay, again clock also 1. So toggle. So 0 is shifted into the 1. The one I have written for my reference. And again 1 is input and clock also 1 input toggle. This 1 is replaced into the 0. That's all. That's why you will going to written like. Okay, fine. Then next one we will go ahead on that one is yes, we will discuss the same. Okay, and synchronous counter is over. Okay, that is called a parallel counter. Another name is called asynchronous counter. Another name of the counter is another counter name is asynchronous counter is called a ripple counter. So first one is a complements. Complement means q bar. So q bar you can give to the second one clock pulse. Second what? Clock pulse. When you will going to execute this one, you want to know about the JK flip flop two rows values. What is that one? J also 1, K also 1. So Q is a don't care. Next state is a Q n plus 1 is a toggle. So clock pulse is 1, it is a toggle. So J also 1, K also 1. Clock pulse is 0, then output is a no change. So if you know that one, it is easy to you're going to fill it. So it is also very simple. Then output value is what is output value? It's a q2. It's a q2 is written here. Then q naught. What is a q naught? It's a first flip flop which is a q naught is written, and q naught bar it is called a complement. Q naught bar, q naught bar. Similarly, so reference is written, okay, previous values and reference, and answer is written on the 1, okay, and this is complement is taken here. The complement value it is coming, that complement value is going here, okay, and that value is going to here, and it is proceeded. Okay, first we're going to look about the second flip flop. Okay, output, what is that one? Clock is 0 and JK is 1. Clock is 0, JK is 1, no change. So no change, 0. 0 means 0. Now it is a clock value is 1. JK is 1. What is that one? JK is fixed 1. Clock value is 1 now. So it's a toggle. Toggle means 0 is shifted into the 1. 0 is moved to the 1. Then now is a 0 is an input. and then clock is 0 and JK is 1. So 0 and the clock is 0 and then JK is 1. What is that one? No change. The same 1. Repeat. Now is a input is clock, input of the clock is 1, JK also 1. So 1 1 means toggle. 1 is shifted into the 0. Error mark. See, shifted. So see 0 1 1 0 0 1 1 0 over. Coming to here's now. Coming to that of first flip-flop place. So what is the previous value? 0. See here, this previous value I have written. Okay, then here is a clock is a 1 and then JK also 1. Answer is a toggle only. Answer is toggle. So 0 is replaced into the 1. Okay, that 1 is I will count reference. Then 1 is replaced into the 0. Then that 0 is I have written here. 0 is a toggle 1 and 1 is reference. 1 is a toggle 0. So that's why. So I have written in that bracket. So 1 0 1 0. I have written 1 0 1 0. That is a Q not bar. First flip-flop bar. Sorry, Q not value. Q not value, not a bar. Q not value. Okay. Then what is a Q not bar? Just opposite. AND gate. 1 means 0. 0 means 1. 1 means 0. 0 means 1. That's all. Very simple to, you will going to memorize it and then you will going to write about that asynchronous ripple counter. The next one we are going to go move for the register. Register is nothing but it is a memory card, memory elements. Yeah, 4-bit okay, n number of the bit registers. So n number of the flip-flop. So 4-bit means 4 flip-flop. Okay, 6-bit means 6 flip-flop. So n bit register as a group of n flip-flops and some logic gates they are using and capable of storing n bit of that informations. So what is the purpose of that one? Same. Okay, what is the purpose of this memory card? It is a retrieve the data, yes, and store the data or load the data. You can say new data you will going to load it and shift the data. So you will going to shift from left to right or right to left, like you will going to do that one. Okay, see that one. Okay, 4-bit. Okay, 1 2 3 4 4-bit as an output. So 4-bit data is loaded every clock signals. Okay, then next one. Yeah. So movement or shift register. So shift register data is moved from that one place to another. How to move? Either serial method or parallel method. So serial input and serial output. So left to right or right to left or parallel input and parallel output, top to bottom. Then here parallel input and then right output. So parallel input, serial output, serial input, parallel output. Then rotate on the right hand side or rotate on the left hand side, like you will going to move the data in your mobile phone. So internal memory into the external memory, how do you going to movement? So this is about that same method. Then shift register counter. There are two counter. One is a ring counter, another one is a shifter ring counter, or another name it is called a Johnson counter. So what is a ring counter? So ring counter means first one output is the second one input, then second one output, third one input, third one output is the fourth one input, fourth one output is fifth one input, fifth one output is sixth one input, and the sixth one output to the first one input. So cycle is closed. So that is called it is look like the closed cycle, that is called the closed ring. So when it is the first one is output, when you will going to give the clock pulse, then it is the first one is a produce as an output. So 1, then 0 0. Then this is the values giving to input on that one second one. So once it is coming, this is active. Then similarly, if I have look at about that left slash, then left slash value is a 1 1 1. That's all. So here is we have look about 6-bit and mode 6. What is meaning of the mode 6? 6 means 0 to 5. Clock pulse is 0 to 5. That is called the mode 6. And the 6-bit is denoted for that is 6 flip-flop. Okay. Then twisted ring is nothing but instead of taking the last flip-flop Q5 bar, you can take it as an input to the first flip-flop. That's all. See, there are 4 flip-flop is used. The fourth one output in Q bar is they are taking to the first one input. That's all. So this is called a twisted ring or Johnson counter. So 4-bit means 4 flip-flop is used. What are the 4-bit? Q0, Q1, Q2, Q3. That is about the 4 bits. What is mode is 8, 0, 1, 2, 3, 4, 5, 6, 7, 0 to 7. That is called totally 8 numbers. So what about that one first one? So clock value is 0, so all the values is 0. When clock value is 1, then first flip-flop it is coming as in 1. Then second pulse you will going to apply. Then first one, okay, it is produce output, it is giving to the input, and the second one also produce 1 1, then triple 1, then 4 1. After that, what will happen? The last one is giving to the input on that one. So due to that one, it is changed it to the 0 0 triple 1, then double 0 double 1, then triple 0 1. That's all about that one Johnson counter. Thank you.